Hello, everyone. It's great to be with you today. We're here to talk about Azure Native Qumulo in action. We put together a 20 to 25-minute webinar just by way of introduction. I'm Ryan Ferris. I'm the VP of Product and Marketing, and I have here with me Dan Models.
Hi, I'm Dan Models. I am the Senior Product Manager, and I primarily currently oversee Azure Native Qumulo.
We have a pretty simple agenda. First, we're going to talk about what problem does Azure Native Qumulo solve. We'll go into some problem statements, a little bit around why we created the service. Then we're going to explore a couple use cases from real customers, but those customers are anonymized. We'll go into some of the details around what they're doing, what value they see from Azure Native Qumulo, and we'll weave in some information about price points as well. And then we'll do a very quick product demo just so you can see it in action. First, we're actually going to kick off the deployment. And we're doing this at the beginning of the
Right.
webinar so that we can, by the end, show you the actual demo. So Dan, take it away.
Yes, and I guess one of the problems that Azure Native Qumulo solves is how much friction it takes to actually get into the product and how quickly you can get into the product. So going over here really quick, let's take a quick view. If you just go into the Azure portal and just type the word Qumulo, you'll probably see Azure Native Qumulo file service pop up. You just click that, go to create in the UI, and you'll be presented with this form. Pretty simple stuff for any resource in Azure. Your resource group, what you want to name the resource slash also the cluster name slash also the machine name in Azure in Active Directory. Region, obviously very important. You want to be in the region that you're in. Your password for your admin, and then the availability zone you want to be in. Typically, you want to try to be as close as possible as the resources that will be primarily accessing the storage system. Finally, the big choice between hot and cold. Hot, we recommend for most workloads. This is workloads that actually are going to be accessing the data with the regular frequency. Whereas cold, we typically recommend for cases where you have very infrequently accessed data, as well as data that lives for a long time. The next thing you'll have to do is also then designate a network, a virtual network, as well as a subnet. The subnet has to be delegated to the Qumulo service, but that is a very simple procedure to do. If you don't have that set up, you can just click Manage Subnet Configuration. Add some tagging if you wish for your own purposes to identify what this resource is for. Finally, you go to Review and Create. Azure in the background is just going to go ahead and do a bunch of checks to make sure everything looks okay on its side. And hopefully here in a minute, I'll just be able to click Create. And the deployment has started. So why don't we go back to the presentation and talk a little bit about why did we build Azure Native Qumulo?
Cool. Yeah, simplicity is key. It just like any other native cloud service, it took you, well, if you were going a little bit slower, it might have taken a few minutes, but yeah, the deployment is really easy. The entire thing end to end takes 12, 15 minutes, Dan, somewhere around there. So before A&Q, let's talk a little bit about problem statements before we launched this and before Azure Native Qumulo came onto the market. So before this, primarily cloud file storages or storage systems and services consisted of fixed infrastructure. Like when you were signing up for a service, be it Azure Files or NetApp Files, or maybe some of the services under Amazon FSx, you would have to reason about how much capacity do I want? How much capacity am I going to need? And you'd have to guess that and kind of forecast that. And how much performance do I need out of my application set that I'm either migrating to the cloud or that I'm building net new? And that's an awful lot of stuff to reason about when the service isn't even live yet and you can't actually use it elastically. So you'd have to kind of look at, is it a small workload, medium, large? What if it actually starts out as small and then grow to large? You'd have to kind of guess at those things. And Dan, do you want to explore a little bit about the nature of having to choose from small, medium, and large?
Yeah, I think that typically comes from an on-premise mindset, right? You think about how Amazon launched in 2007 with S3, and from the start, from the get-go, it was designed to be an elastic service. You could put data in there and you would only be charged for what you used. And you didn't have to, when you created an S3 bucket, you didn't have to think about, well, how fast do I want to make this thing? Or how much capacity do I want this thing to store? You would just create the bucket and start putting data on there. That sort of experience, that sort of ease of use never really made it over to file until now. And the reason is
Mhm.
primarily because a lot of the file storage solutions today in the cloud are built from, or they're just basically virtualized versions of the on-premise software stack. So they take, what used to be physical servers and physical drives and just replace them with virtual machines and virtual drives, which
Yeah.
they're then just running 24/7 around the clock. And if you also think about how typically infrastructure and storage infrastructure is used on premise, it's very common for that infrastructure to simply be used very little compared to what it's capable of, right? So typically, I'm not filling the on-premise storage system all the way. It's running somewhere between 50 to 70% full. And I'm usually not using anywhere near the maximum capacity of that storage system 24/7. Most of the time, the system's fairly idle.
If you're a cloud native builder and you're building something brand new in a cloud native architecture, you might actually take for granted that the services that exist and the services that are offered from Azure or AWS are definitely elastic in nature. That's just a stock thing that you would expect of any cloud service. And it's sort of strange that up until this day and age, file is kind of a little bit old-fashioned, as you were saying, Dan. Like a lot of that mindset comes from on-premises infrastructure and is kind of composed itself in the cloud in the form of what we're seeing on the screen. And so if you're provisioning something like an Azure NetApp Files or one of the FSx offerings in AWS, this is a pretty fair depiction of what you see. These are more like managed volumes rather than managed cloud services. And you have fixed capacity, fixed limitations, fixed kind of performance baked into this one single volume. And that's sort of what you're stuck with. So harkening back onto what you were saying previously, the small, medium, large, if you get that wrong, well, you can't really grow out of the boundary of what you provision originally for that storage system, and that can be quite limiting.
Yeah, and you might have flexibility of occasionally changing the amount of provision performance every once in a while, but that's probably not something you'll actively manage on an hour by hour basis. Also, think about in terms of when there's recommendations of how do you optimize your cloud spend. There's always the recommendations of, well, optimize your compute,
Yeah,
only run instances when you need them to, use Spot if you can, i.e.,
yeah.
try to only sip the resources that you need when you need them. But on the other hand, file is like, nope, just run this big expensive thing 24/7. And that's fundamentally not how you do file correctly in the cloud if you want to be cost effective.
Right. Yeah. Why is
So,
why is my price so exorbitantly expensive with that type of infrastructure with Azure NetApp Files, for example? And that is where
right.
your cost is going. That's where your price is going, to that stuff that's going unused. Yeah. You want to go to the next slide? And then we have kind of the modern approach to file storage in the cloud. And this is a representation of what we built. So Azure native Qumulo gives you storage and performance. Both of those dimensions you can scale elastically. So these demand curves that you see here on day 1 and day 2, if you're bursting in capacity or if you're bursting in performance, rather, if you're going above a certain threshold, in this case, it's 1 gigabyte per second is the throughput that we provision and include with the service. If you want to burst above that, that's totally fine. We can allow you to burst to any throughput capacity that you like, all the way up to 100 gigabytes and then back down again. And the important point and the important takeaway is that you're only paying for that burst surface area above 1 gigabyte per second. That's super cost effective. That is a modern, it's just like a modern elastic file service, or elastic rather cloud service, where you're paying truly for what you use when you need it and when your application demands that level of performance.
And the reason we're able to actually deliver this sort of elasticity and also translate that in the pricing is because we basically rewrote the back end of our system to directly use the correct cloud primitives and have the correct coupling between storage and compute. So we're no longer have this tight coupling between, well, you need this many VMs or this many storage servers on-prem context to have this much capacity. We've completely broken that, and now they're just completely independent. The end result of making the system fully elastic and using the correct storage primitives is this. And Ryan, do you want to talk a little bit through this slide?
Yeah, yeah. we put this slide together just to make sure that our viewers can appreciate the contrast between our lowest price point and kind of the average price point with other competing services. Like at the very end of the spectrum, if you look at the price point of Azure NetApp Files Ultra, you are paying roughly $400 per terabyte per month, versus at our average price point, depending on what region you are in, you could be paying $30 per terabyte per month for Azure Native Qumulo Hot. And you're paying this low price primarily because what Dan was saying, that the vast majority of data we're actually storing in blob or in the object layer. But the performance and all of your file system transactions are being made out of high performance SSDs. So you're getting that price point without having to sacrifice data services or performance. It's just dramatically lowered without having to sacrifice anything that you might be used to from a high performance system. And then the lowest price point for ANQ Cold is, as Dan was saying before, that's for either infrequently accessed or an active archive or things that you're likely not to access very frequently.
And I think to tell that story, it'll be interesting to look at a couple of use cases. These are that have come in since we've launched. We continuously see new activity, new interest all the time, but we've actually seen real workloads come on the service, and I think it's exciting to kind of walk through them because it really demonstrates what the service is capable of underneath the covers.
We made the evolutionary leap in this service in November. We have this customer that onboarded pretty quickly, discovered Azure Native Qumulo, and started migrating from Azure files to our service. This was a use case that we didn't quite anticipate, but it fits our sweet spot, and it fits perfectly our scale around elasticity and the story of scale and growing with the user base. So this customer in Azure Files, they were using Azure Files Premium, had several volumes of Azure Files in their primary region and a couple of volumes that they were managing in their edge region. And so some of the problem statements were that there's a lot of complexity in managing multiple volumes with thousands of users or Azure virtual desktops being stored in the backend, e.g. Azure Files, having to manage that scale, complexity, multiple volumes, and growing with that user base as well. But I think more importantly, the problem statement was the cost, the exorbitant cost that came with a fairly small footprint, only 170 terabytes across 2 regions. That's a massive price point. And Dan, do you want to go into a little bit more detail around kind of what's behind that price?
Yeah, I think one of the things that is important to understand about Azure Files Premium is it does deliver pretty consistent performance, but it is a little bit opaque in the ability to understand when you do have performance issues, especially in a environment like this where you're using FS logics. You have users complaining that they have performance issues, that it's taking a long time to load in, that the desktop experience feels slow. And usually in that situation, the kind of break fix option was, hey, let's take these users that are complaining, let's separate them out on their own volume, and that way they're isolated. There's not going to be any noisy neighbor issues, and that's the way we'll fix the problem. The end result is, there's oftentimes these volumes are half empty or more, and they have many of them. So the cost at the end of the day was looking close to around $60,000 a month. Just in Azure Files Premium, or around $720K a year. They only had about 170 terabytes, though. So if you do the math there, that's around $360 per terabyte per month.
For volumes that were
high.
for volumes that were not even at capacity.
Right, they're not at capacity. Yeah. They're basically oversized because the way Azure Files Premium works is to get more performance, you have to provision more capacity. Mm-hmm. So they often were provisioned to a certain size to ensure that enough IOPS was there so that AVD and FS Logics would work. And so they eventually moved over to us on Azure Native Qumulo. One of the exciting things is once they move with us, all of a sudden we are able to see the telemetry. We're able to see the workload because our system has a lot of built-in rich analytics in it. And so what we observed is, for one thing, they were able to consolidate from multiple Azure Files Premium volumes down to a couple Qumulos, one in each region. They also set up a DOR replication between the two regions so that in case one region had an issue, they could fail over all their users to another region temporarily while the issue was being worked on. And you know, if you look at I think the performance graphs are interesting to look at because they kind of tell a story of what the day in the life is of this company and their employees, and that you could see Monday through Friday. This is a week of time here. So Monday through Friday, 5 days a week, all the employees log in the morning, and you could see kind of the IOPS spikes here kind of top out at the beginning of the day. And then at the end of the day, everyone also kind of logs off at the same time, and FS Logics goes and does a synchronization process where it merges a read-write VHDX with a read-only VHDX so that the next time the user logs in, all the changes are persisted. And you can see that all happening at once, and that causes kind of a 3+ gigabyte per second spike. Our architecture is able to support this easily, and kind of the end result here is around $300,000 a year savings. Or they're saving a lot of money on this. Any other thoughts here, Brian?
Yeah, that was great. I like that you can tell the story just by looking at the graphs, or that you can see kind of exactly what their workflow consists of. I think, or at least the patterns they're in. I think one of the interesting takeaways that we had after onboarding this customer, it's exactly the customer experience that we wanted, that they're moving from multiple volumes and getting rid of all of that complexity and managing disparate instances of Azure Files volumes into one single volume. And from this customer's perspective, they can grow their fleet 2, 3, 4x if they like, and continue with that exact same simplicity. So it lifts this burden of having to manage multiple volumes, and they're lowering cost. And their user experience is ostensibly just getting much better. Low latency at a pretty highly transactional volume, or a highly transactional workload. I don't think you called it out, but we're seeing a peak of just over 80,000 IOPS, and we can go plenty more from there as well.
Another thing this tells us is, I've heard before, when you're doing Azure Virtual Desktop or just Virtual Desktop in general, especially with FS Logics, around 10 IOPS per user during steady state is recommended, and we could see that somewhere between six to 9, depending on how many users log in that day. That seems to be about right because we're in the 60 to 80,000 IOPS range. And the other thing that's important to know is that it's very write heavy. This is a stacked IOPS graph here. So the green is your write IOPS, the yellow is your read IOPS, and you can see that this workload is primarily writes, because if you think about it, users are going in, they're making changes to their configuration, they're interacting with applications. That's constantly making changes to the user profile directories, and that in turn results into writes constantly going down. All right, let's go to the next workload. And here we have Adobe Premiere Pro.
Yeah, Adobe, I really liked how you did it this morning in our previous webinar. So I'll just say a couple things here, and then you should take the con. This is definitely in our sweet spot. Our company has done business with a lot of media and entertainment customers, and editing is kind of in our core sweet spot. For Adobe Premiere Pro, we had a customer that came actually from AWS and onboarded very quickly after they discovered or found the service. They have many artists kind of doing similar things that on-premises artists are doing, but this is a workflow that works very, very well in the cloud, and it's super cost-effective as well. So do you want to voice over or just kind of give some more color around some of these problem statements around too expensive and some of the other things that this customer was saying before they moved?
Yeah, so this customer had both editors that were familiar with an Avid editorial environment. So Avid is its own editor, but it's also a media asset manager, and it has its own storage system. It's a whole collection of different things that bundled together create a full editorial environment. Avid has partnered with Microsoft, and they're able to offer that inside Microsoft Azure. But for their Adobe Premiere users who are not familiar with Avid, are going to not want to switch over to Avid, they needed another solution. The storage was too expensive to use there. It doesn't really make sense to use Avid storage if you're not using the MAM in the editor
Mhm.
And so they were looking for other options. Premium and NetApp files, Azure Files Premium and Azure NetApp files, way too expensive. And
Mhm.
then they did try Azure File Standard, but they found that the performance there was lacking, as well as having some technical issues there. So they were desperately looking for another solution. And so when they switched over to us, they basically the same day we talked to them, they fired up Azure Native Qumulo just as we showed you, and began configuring and setting everything up to get their editors on it. And so these graphs are over a month. You can see that over the month, they're a media and entertainment shop. So they've been constantly creating content. And so every day they add about a new terabyte of data. This dash yellow line is not a limit. It is simply the point in our pricing where our dollar per terabyte drops down to the next tier. So they don't actually have to do anything when they get to this yellow line. The pricing will just automatically start charging them less as they cross over 500 terabytes. And you could also see that this is over a month, but these peaks here are days. So you can see this is a lot. There's a lot of similarity here with the VDI workload. It's cyclical,
Mhm.
right? There's there's every day the editors log in, they do their work, they log off, and then the amount of performance required goes back down. And we talked to them, and they were very concerned about performance. They wanted to make sure that we delivered enough throughput. But the end result, though, is that on the usage side, they actually aren't actually driving the amount of throughput they thought they needed when we were initially talking to them. And most of the time, they're actually staying within the included band of throughput of the service. Finally, like here in the bottom, we have a graph of what their cost per hour looks like. And you can see that most of the time it's in this area, this red area here is just basically the cost of storage. So it's around $20 an hour. Every once in a while, when they go and hit that 1 to 2 gigabyte per second peak, they get charged a bit more for that period of time, and then it goes back down. And this is actually what around they pay, which is mostly just the storage, which is the base cost of the service plus the 1 gigabyte per second, and then only $400 around plus or minus for throughput. So it's very the end result. If you talk about okay, they're around 460 terabytes stored data right now. Their average cost per terabyte per month is very close to what our base cost is, which is $37 per terabyte per month if you're under 500 terabytes.
Yeah, I would add to Dan, the minute by minute metering is another reason why customers can keep their costs low. So as you're looking at those spikes and you're articulating that there's only about 5 of them there that go above 1 gigabyte a second that they're charged. But the granularity with which we meter really means that if you have a spike that goes to, say, 50 gigabytes a second, and that spike only lasts for 20 minutes, then you're only charged within that 20 minutes, and we're not charging you for the entire hour, for example. So there's cost savings there based on the temporary nature of how much you burst and to what degree you burst. We have 160 editors using the service. Dan, as you said, we thought that throughput would actually be a little higher, and we were delighted by the fact that they're staying under that 1 gigabyte threshold for the majority of the time. Awesome. Well, if that 160 editors wanted to grow, or if the company itself wanted to grow that number of editors working for the project to 2 or 3x that volume of editors in order to, say, meet a production deadline. Pretty common within the M&E industry that you're date driven. The show must go on. You have to release by a certain time. So they could increase demand, no problem, temporarily, and we could meet that through, again, elasticity of the service. We could run steady state at 10 gigabytes a second or higher for that matter. And then once those artists start to back off the project, you go back down and then enjoy the benefits and cost savings of low usage and staying under that 1 gigabyte threshold. All right.
Or, if there's, say, like a writer's strike or something that
Oh,
occasionally happens
yeah.
in the media industry, and everyone's off work for a while, you're also not paying for additional performance while that's happening.
Yeah, that by contrast, that wouldn't happen if you pre-provision back in the earlier portion of the deck. If you chose something like a medium or a large NetApp or an Azure NetApp Files instance, you would be stuck with that. It doesn't matter how many people are working on that instance, you're still paying for it. Yeah, let's do the demo real quick and try to wrap it up. And we're already over time, and it's hard to not be over time because it's easy to talk about these workloads. But let's
Right.
do the quick demo and then we can wrap.
Well, so luckily this is a live demo, so we have not been thwarted by the demo gods yet. But so we do have the deployment completed while we were talking. So let's just go to the resource here. As you can see, this is what you'll see when you click into the resource. To connect to it, it's fairly easy. You're just going to grab your IP addresses. I'm going to go ahead and just grab one of these here, copy it, I'm going to put it in here to my browser, paste it. Boom. Advanced. And Zoom is on top of my buttons I want to click. There we go. And I'm going to go ahead and log in. And hopefully I type my password correctly. And we're in. And so there you go. You have a fully running system. As you can see, there is no max capacity of the system. It basically just tells you what you use. I could go, in the interest of time, I'm going to go ahead and keep moving here, but it would be fairly easy then to mount this over SMB and NFS. There's built-in configured shares by default that you can just hit right away, or you can go here and configure shares for different use cases and just get going. It's fairly simple.
All right, cool. Thank you. All right, let's wrap. Let's try to keep this below a half an hour at least. Just a quick flash of our pricing page. You can always go to Qumulo.com and check it out. It's easy to contact us if you want help with either demonstrating this technology, or if you want any pointers or an interactive Slack chat. It's totally fine. Please ping us. But thanks so much for checking this out and viewing and watching. And we're going to be doing these once a month, so higher frequency and with a more kind of targeting of specific use cases. And I think our next one is going to showcase AMQ Cold. So we're going to look a little bit deeper into how to use Azure Native Qumulo Cold for cold data and as an archive, either a deep active archive or for storing data that's truly cold and very infrequently accessed. So thanks again. Thank you, Dan. Cheers, and we'll see you next time.
Thank you.